Hi, I'm Vadim Vladimirsky, the CEO of Nerdio. In this session, you will learn how to ditch your legacy desktop virtualization solution and move to the modern world of DaaS with Nerdio. We'll show you our 6 cost-saving strategies that can help you significantly reduce your per-user costs on Azure Virtual Desktop while ensuring that your IT admins work efficiently and have the most up-to-date DaaS functionality on the planet. Let's get started. Let's talk about Nerdio Manager for Enterprise. Nerdio Manager for Enterprise is a modern cloud-first desktop-as-a-service platform that helps IT administrators deploy, manage, and optimize several Microsoft Virtual Desktop technologies. It works with Azure Virtual Desktop, AVD on top of an on-premises Azure Stack HCI cluster, and with Windows 365 Cloud PCs. Nerdio Manager aims to do 2 things and do it really well. Number 1, it's to minimize the complexity and the difficulty of working with desktop virtualization in the cloud. And the second is all about ensuring that you have the most efficient and cost-effective AVD or virtual desktop deployment possible. If you think about the AVD technology stack, it really consists of 4 components. There is the client application that Microsoft creates for all the various operating systems that are available out there. There is a new version of Windows 10 and Windows 11 multi-session operating system with an AVD agent running on top of it. There is the admin experience, which is typically done through the Azure portal. When AVD first launched as Windows Virtual Desktop back in 2019, there was no UI. It was all command line based. And finally, there is a set of services that Microsoft hosts on behalf of its AVD customers that allow users to connect from their device to the proper virtual desktop machine. Things like gateways and connection brokers, diagnostic services, and other infrastructure backend type services that Microsoft provides as part of AVD. Nerdio Manager is an Azure application that extends the admin experience of AVD with enterprise functionality that IT admins and professionals need in order to manage both small and very large AVD deployments with ease. Nerdio Manager provides benefits in 3 areas that you can see here on the screen. Number 1, it helps you optimize and reduce costs. And it does it both for the hard costs of Azure consumption across compute, storage, and several other things that is going to be the focus of our session today. And it also helps increase the IT admin efficiency of your administrators who are managing the environment by simplifying, automating, and orchestrating many of the ongoing tasks that otherwise take some time in Azure Virtual Desktop to perform manually. The second set of benefits has to do with orchestration and automation to help increase the reliability of your virtual desktop environment in the Microsoft Cloud. Image management is a common example of functionality in this category. The entire lifecycle image management is built into the Nerdio Manager product. Everything from creating the image, sysprepping it, replicating it, capturing, versioning, and rolling it out to your session hosts, as well as updating that image automatically on an ongoing basis, testing it in a non-production environment, and then automatically activating it and making it available for your production users. All of that functionality is fully built in and can be leveraged with ease without any advanced experience in Azure or image management necessary. Nerdio Manager also provides disaster recovery capabilities that help take an AVD host pool and spread the session hosts across multiple Azure regions. So if a single Azure region becomes unavailable, then users can continue working out of a second region uninterrupted. Nerdio Manager also has a self-healing engine that constantly monitors the health of your AVD environment and not only can detect problems and alert on them, but can actually go in and take remediative steps to fix any problems that may arise. The third category of benefits has to do with simplifying management. These benefits are deployment of your Azure Virtual Desktop environment in a very easy and automated fashion, both through a wizard or through a runbook or a scripted kind of way that can let you deploy the entire environment in a completely unattended type of way. But it's also about unifying the management of all Azure components that are necessary for AVD to run. AVD is not just about session hosts and host pools and workspaces. There is Azure Storage, Azure Files, Azure NetApp Files, FSLogix configuration, Active Directory integration. There is other software deployment that needs to happen, log analytics that needs to be optimized. There's lots and lots of Azure components and services that AVD relies on. And Nerdio Manager brings all of these components into a single unified UI and makes the process of managing them very easy. And it also gives you access to role-based access controls that can delegate management of different parts of your system to different groups of users within the IT organization. And then finally, application management is another area that Nerdio Manager helps with, both from MSIX app attach perspective, application installs on images and session hosts, application masking through FSLogix is built into Nerdio Manager, as well as many integrations into third-party platforms that can do MSIX package creation, application testing, and then seamlessly export those images directly into Nerdio Manager for delivery to the end users. So with those things at a high level, let's dig in and look at specifically what Nerdio Manager can do from a cost perspective and how it can help optimize your AVD environment. So in this example, we're going to be looking at a multi-session host pool deployed through AVD. We're going to make a few assumptions. We're going to assume 192 users, but these numbers scale linearly if you go up from here. We're going to assume a heavy user type, which means 2 users per virtual CPU. We're going to assume a 32 gig of RAM and 8-core Intel VM with a 128 gigabyte premium SSD disk, 20 gigabyte user profile stored in Azure Files Premium, with users working an average of 50 hours per week and using the pricing from the South Central US region. And if you were to deploy this environment in an unoptimized way, it would cost you about $5,000 or $26 per user per month on average, which is a pretty decent starting point if you think about everything that's included in AVD and all of the infrastructure that this encompasses. But as you can see, we can do much, much better and get that cost down pretty significantly. The first 3 optimizations listed on this page have to do with compute optimization, and the next 3 have to do with storage optimization. The first one, VM power management, is really the most obvious one, just making sure the right VM is on at the right time and it's powered off when it's no longer needed. As the users are logging in, VMs can be predictively turned on so they're not waiting for them to come online, and then be turned off when users are no longer logged in. However, even with VMs that are turned on and off, you're still paying for the cost of that Azure storage, that Azure OS disk, the operating system disk attached to the session host VMs. And this is where the second optimization is really helpful, called just-in-time provisioning. Just-in-time provisioning allows Nerdio Manager to build session host VMs as they're needed and then destroy them and delete them as they're no longer needed later in the day. What this allows you to do is accomplish 2 beneficial things. Number one, it reduces the cost of any of that storage that would otherwise be necessary for VMs that are powered off, because that VM is actually deleted and recreated as needed. So there's no storage being used and you're not paying for that extra storage. But the second benefit is that this helps keep all of your session host VMs fresh on a day-to-day basis, because it's always provisioning them from your image, layering on any necessary applications, getting them joined to the domain and available in AVD, all without being subject to that configuration drift that can sometimes take place in environments where VMs are not rebuilt frequently enough and just sort of sit there and get patched as time goes on. The third optimization is all around reserved instances and reserved instance analytics. Typically, reserved instances and autoscaling is not used together, but what we realized is that with autoscaling, even though the cost savings is greater than reservations, because even a 3-year reservation provides 60% savings, whereas autoscaling is typically 75 or so percent savings on a monthly basis. However, there is a way to make even deeper savings on compute by reserving some capacity to cover all of the cores and all of the CPUs that are being used for that auto-scaled environment. The difficult thing is to know exactly how many CPUs need to be purchased and what type of VM should be used. And this is where Nerdio's reserved instance analytics comes in. It analyzes the auto-scale behavior from the prior 30, 60, or 90 days and can predictively tell you how many CPU cores of what type of VM should be purchased in what region to make sure that you have the best possible compute costs, even though you're using autoscaling. Now let's move on to the storage-based optimizations. Optimization number 1 is operating system disk autoscale. So recall that we assumed a premium SSD 128 gigabyte disk for our session host VMs. And the reason for that is because we want our users to have best possible experience, so we give them the fastest possible disk. But when those users are not logged in and those VMs aren't being used, those disks are still running the storage meter and you're paying them at a high rate. This is where Autoscale for disks comes in, where when a VM is powered off, that disk is automatically converted from a premium SSD to a standard HDD spinning media, which is about 75% less expensive than the premium SSD disk. And when that VM powers back on, that disk is converted again back to premium SSD, allowing the user to have the best possible experience when they're logged into the machine and allowing your business to have the best possible cost when those machines aren't used. This doesn't add any additional time to the machine power on and power off process, maybe a second or two at most, and is a very seamless process from an end user perspective. The next storage optimization is OS disk shrinking. So a standard typical disk that comes out of Microsoft Azure Gallery is 128 gigabytes. And if you were to log into one of these Windows 10 machines, you will see that over 90 gigabytes are actually free. So unless you want to be paying for that extra free space, or if you need it for lots and lots of applications that you're installing in your images, you can actually reduce the size of your OS disks down to 64 gigs and save quite a bit of money on the storage costs. And then finally, we have our FSLogix disk shrinking. FSLogix is a profile containerization technology that allows you to offload the user's profile onto a shared storage. And in our example, we assumed we were going to be using Azure Files Premium as that storage, where you pay for the usage of that file share and the quota that you set. The challenge with FSLogix profile containers is that initially these VHD files are thin provisioned, and as users begin using them, they start growing, but they never shrink. That means that if a user downloads a large file into their downloads folder and then later deletes it, that VHD file will expand on top of Azure Files and will never shrink again. So you'll be paying for that white space, that free space that has been now freed up within the user profile, but is still taking up the space because the VHD files have now grown. What Nerdio Manager does is it can go into each and every FSLogix container and shrink it and compress it by removing the white space from within that profile, reducing the size of those VHD files, and then going to the Azure Files Premium and reduce the size of that file share so that you have the best possible price without having to pay for that white space. And as you can see, we are started with a $25, $26 per user per month cost, and we end up with less than $5 per user per month, which is pretty tremendous savings of up to 83% in this particular example. Now let's actually jump into Nerdio Manager and see what this looks like in practice. So let's take a look at Nerdio Manager. We have a workspace that was created right here. Let's go ahead and set up a new dynamic host pool. So what we'll do is we'll set up a new dynamic host pool, Ignite 2022. We will set up our desktop experience to be a multi-user or multi-session pooled desktop, although we could use single user or publish remote apps. We're going to select one of our directory profiles, which happens to be a Active Directory pointing at a specific OU in my lab environment here. We will use the latest version of FSLogix and have Nerdio Manager manage the installation and the configuration of our FSLogix containers. We will give this a name. We're going to use a prefix. It will just append a unique prefix or unique suffix to this name. We're going to choose a network. This could be in any region, in any subscription, or even any Azure tenant. In our example, we'll go with a North Central US. It's going to make sure we have sufficient number of IP addresses available before allowing us to deploy. We'll choose a Windows 11 image from our list here. So let's go with Windows 11 with Office Pro Plus Generation 2 multi-session VM. We're going to choose a 4-core Intel version V5 VM with 4 CPUs and 16 gigs of RAM. That's going to be a list price of about 19 cents per hour. We will go with a P10 OS disk. So this is going to be our premium SSD disk from the list here. We're going to choose a resource group. We can do quick assignments of a couple of users or a user and a security group. We'll do that right here. And we will click OK to commit all of these settings and have all of these objects created for us by Nerdio Manager automatically inside of Azure. Now what you'll notice is though I specified almost all the parameters of this host pool with the exception of one key thing. I did not say how many VMs should be added in this host pool when it gets created. And the reason for that is because the sizing of a dynamic host pool is typically controlled by Nerdio's Autoscale, where you define the parameters of what is the minimum size of that host pool and what is the maximum size, and Nerdio Manager handles the rest of that configuration. So first thing we're going to do on this page for Autoscale that came up as soon as the host pool was created is we're going to turn it on. We are going to see that all of these settings that we specified on the last page are visible here, and you can see that any changes can be made at any time. You can change the image and the network and the VM size and apply these changes, and they will apply to newly created or re-imaged VMs. You'll also notice that we selected a premium SSD disk as our running OS disk, and I'm going to set this to standard HDD for the stopped OS disk. This is that OS disk scaling that I mentioned earlier, where when the VM is stopped, it will get created to standard HDD, and when it's started up again, it gets created back to the running type, which is premium SSD, to give the users the best possible performance. We'll then define our host pool sizing. We'll say that we want 3 hosts to start with as our base capacity. We want one of those hosts to be always running, while the rest of them could either be on or off depending on the user demand. And then we'll have 2 hosts that could be our burst capacity, which is where that just-in-time provisioning comes in that I mentioned earlier, so that these 2 VMs will only be created if required by the autoscaling engine, depending on user demand. So unless there's users that are logging in and are consuming all 3 of the base capacity VMs, these 2 will never be created, and there is 0 cost associated with them being in this scenario. Then we go down into the scaling logic section. This is where we define what determines when to grow or to shrink the environment. We can use CPU usage, RAM usage, average active sessions, ignoring disconnected ones, an available sessions buffer, or we can do this purely based on user-driven behavior. And we can even combine different triggers and scale based on CPU and RAM, for example, at the same time. In our example, we set it such that if the utilization goes above 65% for 5 minutes or longer, it will start adding VMs one at a time. We'll first power on the base capacity and then eventually start adding burst capacity. And then when it falls below, let's say 30% and stays there for 15 minutes or longer, then the system will begin scaling in, which is first going to remove burst capacity and then power off the base capacity VMs. We can set up scale-in restrictions. For example, if we don't want to scale in until after 6 p.m., we can set scale-in aggressiveness, which will determine what happens to active users while it's scaling in. And we can even set up pre-staging so that Monday through Friday, let's say Monday through Friday by 8 a.m., 4 VMs can be ready to go for us, and users don't have to wait for new VMs to power on. This will pre-stage the necessary capacity. We can also enable auto heal, which will repair any broken host. So for example, if a host is unavailable but the VM is running, or if it lost its domain trust relationship, or if its logics is not healthy, or any of the other conditions that can be detected by the AVD agent, you can tell the system what to do to repair that problem. For example, if a host is unavailable, we wait for 10 minutes to make sure it's not a transient problem, and then we can first restart the AVD agent. If that doesn't fix it, we can restart the VM itself. If that doesn't fix it, we can reinstall the AVD agent from the latest version and re-register the host pool. And if that doesn't work, we can finally delete the VM and recreate it automatically and get it back into production. So this is the type of power that Nerdio Manager brings to you in an easy to use kind of way, where you can define all of the scaling technologies and cost saving technologies that I explained that are available. And that's not even an exhaustive list, it's just the 6 most popular ones, and save 50, 75, or even 80% on the cost of your Azure compute through the use of Nerdio Manager. Typical customer of Nerdio Manager saves enough in Azure to pay for the cost of Nerdio license within the first 6 days of each month, or 6.5 days of each month. And then the rest of the month, all of the savings drop to the bottom line and make your AVD and your virtual desktop deployment in Azure as efficient as possible. I hope you found this session useful, and we'll take the opportunity to go into the Azure Marketplace and do a test of Nerdio Manager application in your own environment and see what kind of impact it could have on the costs of your AVD deployment. Take care.